Michael Farzan, PhD, is professor and chair of the Department of Immunology and Microbiology right here in Jupiter at Scripps Research. His research expertise includes coronaviruses and HIV-1, which is a virus that caused AIDS. Professor Farzan has developed vaccine prototypes for both HIV, coronavirus, and he's now advancing second generation COVID-19 vaccine particle engineers, tell me if I get this right, to elicit protection against multiple variants of the pandemic, coronavirus, and to work with multiple types of vaccines. The other thing people should realize is Dr. Farzan is a native of Palm Beach County. He grew up in Boca Raton and received an undergraduate degree from Harvard College. He earned his PhD in immunology from Harvard Medical School. And he was appointed assistant professor at Harvard in 2002 and left as a full professor in 2012 to join the Scripps Research Florida campus. His early contributions to the coronavirus field include the co-discovery during the first SARS epidemic of the ACE2 as a cell receptor for infection and identification of the coronavirus spike receptor binding domain, RBD, as a virus first point of contact with cells. These discoveries have proven crucial in the fight against SARS, MERS, and now COVID-19. Dr. Farzan is also the founder of a biotech company in Juno Beach, Immune, which is developing antibody therapeutics against HIV, COVID-19, and other diseases. So that's quite a resume, and thank you for being here tonight. So we've got people have been submitting questions regarding the current vaccines, and what I thought we could do is talk about the current vaccines, the Moderna, the Pfizer, and the J&J that people are currently receiving here in the United States, and understanding a little bit about the technology that was used. And questions are, people want to know, what are the differences between them, and how did they come about so quickly when vaccines have taken so long in the past to develop? Can you talk about that for us tonight?
Yeah, that second one's a great question. So maybe let me start on the three vaccines that you mentioned that are available to us right now. The two of them, as probably many people know, are the Moderna vaccine and the Pfizer BioNTech vaccine. And both of those are based on mRNA technology. And that's part of the answer to your second question. Why did that come up so fast? But the J&J vaccine, a different delivery system, also came up quickly. And also, in addition, I think we'll soon be seeing a fourth vaccine in Novavax, which is also a different kind of vaccine because it's actually more conventional. It's based on protein delivery. So we can. I'm happy to talk about each of those in greater detail. But the question as to why this came up so fast is in part because it was an easy job, in part because we had a good deal of insight flowing from the SARS-1 epidemic, and I think in part because of the ongoing work on vaccinology from HIV in particular has paid off in a big way. So both the mRNA vaccines and the J&J vaccine were originally developed, being developed as HIV approaches, and then they rapidly moved over to COVID or SARS-CoV-2 when that emerged. So I think we were ready. We had a bunch of good technology sort of in the hopper waiting, and we understood kind of what we needed to do, but also we were lucky because this is a relatively easy virus to vaccinate against. For reasons we understand fully. And that is in stark contrast to something like HIV or even flu. So we, in the count your blessings part of this, be very, very grateful that this was an easy virus in a sense.
We talk about the efficacy of these different vaccines, and is one better than the other?
Yeah, so the answer is yes. And the ones that appear to be better, at least against the original variant and against one of the major circulating variants now, which is, we call the UK variant. There are three kind of winners in efficacy at this moment. The first two winners are the mRNA vaccines again, Pfizer, BioNTech, and Moderna. And the equivalent winner again is this Novavax. It appears to be about to be FDA approved. So that's important to say, that they're both about 95% efficacious. And if we had infinite supply of all of those, I would say that's great. The J&J vaccine is less efficacious. It protects almost everybody, basically everybody, from severe disease. So it'll save your life. But it protects people from infection at about 70 to 75% level, rather than more like 95% level with the previous vaccines I just mentioned. So what that means, now it's a single dose. And in fact, if they gave it a double dose, they'd probably get the efficacy higher. There's some technical reasons why that's a challenge, or why they chose that strategy. But at the bottom line is, if you're in line and you have a chance to get the J&J vaccine, get it, because for two reasons. One, it'll save your life, a very good reason. And then the second reason to get it is that almost for sure, with all of these vaccines, in a couple of years, we'll be needing to boost. And we'll be needing to boost for two reasons. One is these vaccines the efficacy of these vaccines will go down. And the second reason is new variants will emerge that the vaccines will become less and less effective against. And that second point is very important. It's an almost inevitability that new variants will emerge, and those variants will more easily infect you. But it is also true that if you've had any of these vaccines, they are less likely to kill you. It is, let me say it this way, it's very easy to stop you from getting a lower respiratory tract infection, and therefore all the bad things that go along with that, including hospitalization, needing ventilation or worse. That's very easy to protect against. It's much harder to protect against a transient upper respiratory tract infection that you're going to move from person to person. You might show some symptoms. So bottom line is, we're all going to be needed to be boosted in a few years. And right now you want to, number one, save your life, and you want to, basically kind of return to a normal business, knowing that there may be some marginal advantages to the double dose Moderna or Pfizer. So that's the best I can say. I think over the long term, I think we're going to protein vaccines and mRNA vaccines will predominate, because there are some technical challenges about giving adenovirus vaccines a second or third or fourth time. And that's probably something we're going to end up having to do over a number of yeyears.
So you spoke about mRNA. What is that? Is that like the live virus?
It's yes and almost certainly no at the same time. So there's two very broad ways. So what a vaccine wants to do is to make something that looks like the virus to the immune system, and to fool the immune system into reacting to that thing, and giving a reaction so that it'll be more ready the next time. So that's, I think everybody understands that about vaccines. Now, there's two general categories of vaccines you can do that. You can deliver directly something that's basically a protein. something that looks exactly like a protein that's on the surface of the virus. All of you have seen this picture of the virus, the red spikes that come out of that. Just take a piece of that, and that's a protein. Take hold of that and inject it into you, and that's a protein-based vaccine. Now, that's one way to do it. Just make the protein in a big vat and put it into you. The other way to do it is to basically give the message, the code, to make that protein from your own cells. And that, to get to the point of whether it's similar or different than a virus, that's what the virus does too. It injects, in the case of a coronavirus, a very long piece of RNA and makes a lot of proteins and replicates and moves forward. But it's training your cell to make proteins. Now, what mRNA vaccines do and what adenovirus vaccines do is they train your cell to make one protein, the protein that your immune system best reacts to. And that happens to be the one on the surface of the virus, the one a major arm of your immune system can see. And so what's happening is when you get an mRNA vaccine, the RNA codes for how to make the protein. And the protein that it makes is the thing that fools your immune system into thinking that it's seeing a virus. And so it makes antibodies against that thing. And so adenoviruses do that. They introduce a piece of DNA that gets turned into RNA that gets turned into proteins. mRNA directly takes RNA into proteins. And then Novavax, for example, will just put a protein into you. And there you have that protein. All of them have the same net effect. The immune system is seeing that protein and making antibodies against that. And then those antibodies block the ability of the virus to get into the cell.
Interesting. When Will, and you touched on this, but you talked a little bit about the variants, and we're hearing about some of these variants are apparently challenging.
Yes.
Will our current vaccines that we have available today continue to protect us against the variants, or is there a limitation?
So that's a hard question to answer with a yes, no, because I think people need to think of immune responses on a bell curve. So what happens is that bell curve is moving. So if you think of a bell curve and you think of a line where people are protected. Now, when you think of a new variant, you think of that bell curve moving over. So more people are on the unprotected side of that bell curve. And there are certainly variants from Brazil, from South Africa, and actually a variant now in California around Los Angeles area that moves that bell curve pretty significantly. So that and the consequence of that is you are less likely to be protected, but nonetheless, your immune system still has a head start. So you're still much less likely to end up in the hospital because of that new variant. Now over months or more likely years, we'll start seeing variants that that our vaccines will not really protect us against very much. We're not there yet with any of the variants, but we will in the future see those variants. And with those variants, we'll have to design new vaccines that include those variants. So already the major vaccine manufacturers are combining, so the original 2019 or Wuhan variant with the variant coming from South Africa in the same formulation and delivering that. And the hope and expectation is you continue to be protected against the original variant, but now will be better protected against the South African variant. Our difficulty is there are so many people infected right now, and we're moving into an era in which immune selection will be the driving force of the viral evolution. So those variants are going to happen faster and faster, and we need to get, ahead of it. We need to play a very effective game of whack-a-mole while at the same time lowering the number of people who are infected, so they'll lower the chance those variants emerge.
So that actually leads to another question then. Is that why we get recommendations from like the CDC and our public health officials that we still need to wear masks and social distance to?
So now we find ourselves in the position of the 20-year-old where we're pretty confident that we're not going to really die of this thing. But we know if we get infected and move it on, we will not be helping other people. And that's going to be pretty much our situation as a vaccinee with the current variants. We will be protected from serious harm. There's still a reasonable likelihood we could be infected in our upper respiratory tract and transmit further. And the big problem is if we all do that, yes, we will be making new variants that will come and bite us later.
Wow. Can these vaccines change our DNA?
No, absolutely not. First of all, there's two layers of which that is simply not true. The first layer that is simply not true is the cells it goes into, it does not change the DNA of those cells at all. So even the kind of mild worry where you're going to change the muscle cell, change the DNA of a muscle cell. Now, scientists like me knows that if you change the DNA of a muscle cell, nothing happens. It's a terminally differentiated cell. It's not prone to transformation to turn it into a cancer. It is fine, but it doesn't do that safe thing. And what it's even more further absurd as I hear this, that people worry about changing your DNA in such a way that it gets transmitted to your future children. And that is even less true. And so it's just, that people hear that RNA is kind of like DNA, and DNA is the code for everything that we do. And so that, they put two and two together without a lot of information.
Okay. What about this idea of tracking chips and things are, being inserted in the vaccine so that, Bill Gates and these tech companies can track us? And is that possible?
Yeah, well, I think that you probably appreciate that's also absurd. There's nothing in that material that's distinguishable from the outside than your protein and your RNA. So every cell of your body has a ton of RNA, a ton of protein, and a ton of DNA, and you put a little bit of extra RNA into your cell, say, there's just no, I could never, it's just absurd all the way through. There's no technology that allows me to track that.
On the current vaccines, do we have any sense of how long they're going to be effective for?
Yeah, that's a rubber hits the road question. So initially it looked like the half-life would be relatively short, but the data now suggests that it plateaus out at about 30% of our peak, 20 to 30% of our peak potency. And that's good enough for a long time if the virus itself does not change. So the expectation would be if we do not have variants that continue to change and continue to be selected in the face of our own immune responses, then these vaccines will last a good length of time. When the over-under might be 2.5 years or something like that. We work through that. That's somebody's back of the envelope calculation. But the main problem right now for us is that the variants are coming fast and furious, and we need to prepare as vaccinologists for that, and we also need to prepare as populations for that.
Okay. Are there people who should not have the vaccine that it's not safe for?
Well, certainly there are risks associated with individuals who are prone to anaphylaxis. Those are well known, well stated, and this is part of the reason why, after some of you have received your vaccine, you had to sit down for 15 minutes and make sure you're okay. There are also individuals, and this is the reason I'm sort of hesitating is because the question comes down to children who don't have pre-existing conditions, meaning conditions that would increase their risk of being infected. And the current vaccine trials have not studied children of that nature. And so I think it's something for which the data remains out. And so I'm talking about very healthy children, not children who might have, for example, asthma or obesity or something like this, which might make them more prone. So the only doubt in my mind that anybody should get a vaccine, and I leave this as just an open question, not a resolved question, is whether healthy children right now in this month should get vaccinated. The rest of us, we would certainly always rather have the vaccine than have the virus. The risk of the virus are far worse than the risk of any vaccine. And this is as good as it gets here. So for the rest of us, it's an absolutely easy call. It's just the lack of symptoms in children, make it a little harder call, and that we'll leave that to the people who are doing the clinical trials and other kinds of experts.
Okay. What's the difference between, because the Moderna and the Pfizer both are 2-dose vaccines. Is there a difference between those 2 doses?
Well, there's a difference in the amount of mRNA you receive. There's a little bit of difference in the lipid formulations, but for all intents and purposes, for a receiver, you don't care. One is the Moderna, you have to delay 4 weeks. Pfizer, you delay 3 weeks. Actually, that was just somebody's judgment call early in the process. They got stuck with that. Probably 4 weeks is slightly better for both vaccines. 3 weeks is fine for both vaccines. So for the end user, there's really no difference. There's some interesting scientific nuggets in the formula, what they're formulated with, and a little bit of differences in the non-coding sequence that make it interesting. But for a user, just if you have access to one of those, get it as soon as possible. Do not pass go.
Okay. How about this? This was a question. Would it be better and more effective if I had one vaccine and then I went and got the other one? And would that give me more protection?
Depends. So I'll say it sort of bluntly. If I had the J&J vaccine, or even, unfortunately worse, the AstraZeneca vaccine, I would probably attempt to boost that with one of the current vaccines, including another J&J vaccine or something like this. Or I'd cross AstraZeneca and J&J since they use different capsids, slightly different delivery systems. If I had a Novavax or an mRNA vaccine, what I would do is I would wait. I would feel very comfortable. I would wear my surgical mask, not my N95, everywhere I go. And I would wait for a time frame when vaccines are available that could boost against the new variants. And the new variants have settled out a little bit too. We're just in the early stages of this. So I think, Moderna, Pfizer, Novavax, just get it once and move on with your lives. The J&J and AstraZeneca, I might consider getting one dose of one of the others.
Okay. Have you had any opportunity to study or understand the vaccine that was developed in Russia? And I think there's one in India as well. And
yeah,
well,
I know that the vaccine, the ones that I know, I think that the one in India is just another knockoff adenovirus-based vaccine, as is Sputnik 5, the Russian vaccine, which actually ends up efficacy-wise very good. And it's very good because it's like the J&J vaccine, only give 2 doses and with slightly different delivery systems. So they kind of circumvent the problem with the J&J vaccine of giving the same vaccine twice. So it turns out that's pretty good. That's very good, actually. And that's pretty good news for the world, because I think there will be a lot of countries in the world that get that vaccine. Not so much with Sinovac, which is a whole killed vaccine. And that unfortunately used the first version of the S protein, which was less, the first thing that infected us was an unstable S protein. And so anybody who started with that didn't try to stabilize it, for example, ended up with a weaker vaccine. And so unfortunately, the Sinovac falls in that category. So there's I don't think that impacts so much, but there are countries in the world that are using that. That's got about a 50% efficacy, even with the current variants, and that's unfortunate. It's a breeding ground for variants.
Wow. When you go to get vaccinated, are you supposed to avoid any medications or anything prior to getting vaccinated?
Nothing's indicated, and there's no really compelling reason for doing so. If you really want to get subtle into it, the time of day you get vaccinated with a protein vaccine can matter, because it turns out morning is better. You get a slightly better immune response, but it doesn't matter. By this time you get that second dose, it's a blowout over the top response. So get it in the evening if you can get it. That doesn't even matter with the mRNA vaccines, because they kind of ooze out of your muscles slowly. So nothing matters in that case. And so, yeah, don't hold off on your medications. I think maybe if the only thing is check with your doctor on something like a corticosteroid or something that would be immune suppressive, but that's a check with your doctor. Don't talk to, the academic on the Zoom meeting.
Okay. What about taking other vaccines, shingles or pneumonia or other things that people normally
Yeah,
are
no,
taking?
vaccines work very well together. There may even be a little bit of a synergy between those, because once you get the immune system kind of riled up, it kind of gives you a better result. So anyway, but the basic point is don't worry about it. Don't hesitate on any of those. I doubt you're going to be able to get them both on the same day, but if you can, go ahead. And eventually you'll be getting flu plus COVID vaccines on the same day, I would imagine.
All right. I'm going to try and give you this question and see if you can answer it. It says, both my husband and myself have anaphylactic reactions to medications in the past. Me to lisinopril and him to IV dye. Is it safe for us to take this vaccine?
It is safe with an EpiPen. So that's the first answer. But I don't think, the reason that the mRNA vaccines tend toward anaphylaxis is due to a single component. It's presumed to be a single component in their lipid nanoparticles in their delivery system. So that may be an indication to go to a J&J vaccine initially, or wait for the Novavax vaccine. Even so, I would, keep an EpiPen handy that it won't hurt. And so that would be my thought on that. Again, consult with your doctor on any of this, but if me, I would still proceed sort of deliberately to get a vaccine. I may lean into a J&J or Novavax in that case.
Okay. I understand you're developing a new technology. I'm sort of shifting a little bit here.
Sure.
So can you tell us a little bit about what you're working on? And is
Right.
this like second generation or third generation?
Yeah, it is a new generation. I guess it's pretty much second generation. So first of all, a couple of disclaimers. When we think about a vaccine, we think about how to deliver the protein we're trying to emulate, and then what is the protein we're trying to emulate? What is the viral protein we're trying to make the immune system think it's seen? So we've been working very hard on that second piece to talk about what is the optimal thing for the immune system to see. And it turns out that everybody in the first generation did one thing. They make the immune system see a very long, to put a number on it, 1271 amino acid protein, a very big protein. Unfortunately, there's a lot of wasted effort in that 1,271 amino acids, 1,271 units, because all of the good immune response, all of the parts of your antibody response that stop the virus, they're all focused on a little piece that's 197 amino acids, to put a number on it. Again, it's about a 1/6 of what people are delivering. And we know this in animal studies, what is a better immunogen is that little 197 amino acid piece that you want the immune system to focus on. And what's even better than that is if you can make it in a nice symmetrical ball and put multiple versions of that together. And what's even better than that, what we like about it is we can put different pieces of the virus, not different pieces of virus, different variants of the piece of the virus that we're interested in on the same vaccine. So the advantages of the antigen we've made. So remember that this is an approach that we can deliver with mRNA. This is the approach we can deliver with adenovirus. This is the approach we can deliver as a protein. What's advantageous about this is we can present all the different forms of the viruses that are coming out, and we get a stronger response for each of those delivery systems. And because for several of those delivery systems, your muscle has to make the protein, the muscle makes it, this variant is optimized so your muscle makes a lot more of it. So that either means you get a stronger response or you lower your dose. So those are all very, very good things about this particular antigen. And so that's what we've got. And there's one other, I sometimes think it's cute thing, sometimes think it's important thing, is we can dry this down, freeze dry it, and send it to a collaborator by conventional mail or FedEx or something, no cooling whatsoever. And he or she can reconstitute that with water and another powder and do immunogenicity studies in animals with that. So we're not sure, to be honest, whether that property of the vaccine is going to be important. We know that the property involving focusing the immune system on the right thing and being able to present multiple variants is important. And right now we're in the process of trying to convince different vaccine manufacturers with different delivery systems that this is a better thing. And that's where we are right now. And so that's the entire story as we know it. Now, one thing to say though is that some of the people on this chat will remember Betamax and remember how Betamax was actually a better technology, but could not break into the market dominated by VHS video technology. By the way, my young postdocs have no idea what I'm talking about. And so our concern is that each of the major vaccine manufacturers, who after all do hold this manufacturing capability, will stay committed to their original version. But their original version has significant limitations if we're talking about new variants. And so we may have some ability to wedge in there. But that's kind of the whole story there. People ask me how long it will take, and I can say it will be the best case scenario is 6 months to a human safety trial. We don't expect any safety issues with it, and or to infinity if we can't get somebody to believe our arguments.
Interesting. You talked about a Nova vaccine?
Novavax.
Novavax. That's something I hadn't heard of before.
Yeah. So they're about to be FDA, they're on the cusp of FDA approval. It's a protein-based vaccine based on the same antigen as everybody else. So everybody's using the same antigen, antigen, but they make it as a protein. And so they have a process whereby they, it's complicated, but they bleb it from a cell. It forms sort of particles of 3 or 4 of these spike proteins. And then they sort of concentrate that down and essentially inject it to you. They make sure it's clean and everything, inject it into you. And it's a very good vaccine because its efficacy against the original virus is comparable to the mRNA vaccines. It's going to be an interesting issue to see how well they do in the marketplace right now. But I think they will be FDA approved. I give it I'm not sure, about a month. And then the question, how many doses will be available, how many doses will come to Florida, et cetera. I'm not sure.
Interesting. Do you know how they decide what doses go where? Like I heard the other day that we're out of J&J in Florida and we'll be like that for a few weeks.
Yeah, I don't. It's a little bit opaque to most of us, and I think that's a shame. But I think at the moment, everybody's just in a mad rush to get basically any of the FDA approved vaccines into arms. I think that the subtle differences among these vaccines do not matter as much as getting, 70, 80% vaccinated.
Interesting. Okay. What would you tell people who are at lower risk to develop, bad complications from COVID-19? Any thoughts about maybe potential long-term impacts, or what would you tell people who may be hesitant?
I would say avoid getting this illness if you can. Even what some of the symptoms that sound almost comical, like loss of smell, represent loss of cells that you want to keep. And it gets worse from there. So there's simply no reason to get this virus if you can avoid it. And the difference between, the core message here, I guess, is the difference between the vaccine and the disease is really different no matter how young, no matter how healthy you are. And so that's what I would just avoid getting this virus if I could. Many people, it has to be said, sort of survive. They don't seem to feel bad effects, but I don't see any positive reason for getting this virus.
And is there any way to know sort of long-term what the implications based on understanding this virus and how?
Well, there's not any way, but we know it's not good. If it's a serious case, you can have lung scarring that will basically limit your breathing for much of your life, for the rest of your life, basically. If it's less severe, it depends on, for example, the rate of rewiring and repopulation of the neurons that it's taking out from your olfactory tract upward. It likes to attack your kidney. That's never a good thing. Kidney is very rich in the receptor. It attacks your endothelial cells, and so different parts can become ischemic. You can get not enough blood flow. This is just from my perspective, it's a game of Russian roulette that I would not advise anybody to play. And right now we have very good options, and we should be thanking everybody for these very good options that are becoming available to us. And yeah, avoid this virus.
There's been, and I don't know if this is something you can talk about, but the question of the masks and the efficacy of masks, and people saying they don't work, they do work. They limit your breathing, and you're gonna,
Well, limit the breathing is true. It is harder to breathe, certainly through N95 masks, which are the ones that protect the world from you and you from the world. The truth is the surgical masks do a better job of protecting the world from you than you from the world. But and I think it will be an important courtesy for us to continue to wear these even as we're vaccinated. And so I think, Yeah, I recommend for anybody who is at all at risk to wear an N95 in a, you know, a larger environment like a supermarket, and then in a very comfortable but still social setting where you're, you know, you might be surrounded by vaccinated people. If there's, you know, 5 vaccinated people, you still maybe want to wear a mask, and then you're down to your, you know, your spouse, of course, or your kids or something like that, and you're all vaccinated. That's you know, you're okay. So the masks absolutely do work. You know, different masks work for different purposes. And I hope we will get to a courtesy mask wearing even as we're vaccinated.
I apologize. The questions are coming in, and so they get brought in and dropped off. So let's see. Not okay. This is feel free to. Let me just ask this. This is not everything works for everybody. So a percentage of people will most certainly die. Do you feel that these deaths are necessary so other people will live?
Not exactly. I mean, I think the question is actually underneath this a good one, because we tolerate a certain amount of death associated with flu every year on the order of 20 to 40,000 people. And we can only hope we get to that this year for COVID, or next year for COVID. But after that point, we got to look at those 20 to 40 to 60,000 people, depending on whether the year is intense for flu. And we have to get those 20 to 40 to 60,000 people, you know, eliminated for COVID as well. And what does sort of is remarkable to me is we have the technology for doing all of that. But we need to be more aggressive about implementing it, make a larger commitment to the population to sort of seeking out and eliminating infectious disease among other diseases.
Do you think we could eliminate a lot of the deaths that we have from traditional flu?
Yes.
By some of the things we learned by
Yes,
how we manage
absolutely.
COVID?
Absolutely. I mean, the first thing to learn is how best we were in the process of learning is how best to handle variants, meaning how do you achieve breadth in an immune system? And that's coming, and that will help us immensely with flu. And the second thing is a lot of investigators are developing tools for analyzing your immune responses in the kind of detail that will helpful for us to really give a good evaluation for different vaccines, including the Holy Grail, which is universal flu vaccine that everybody will get. And so we will be getting to broader and broader vaccines, and vaccines that will be more indicated for more and more people. So yes, I absolutely think that I'm hoping that the silver lining in the COVID epidemic is it's going to jumpstart our fight against all, well, starting with infectious diseases.
Wow. Is there any chance that there's going to be long-term implications from taking the vaccine? Yeah.
I mean, there is always a risk, but I think most of our expectation is that 95 to 90%, 99% of serious side effects emerge within the first months of any intervention. And since we haven't really seen that here, we think we're in a place where there's simply diminishing likelihood, given the mechanisms of the vaccine, that there will be a long-term consequence to the vaccine itself. So remember, these vaccines and all the material that you put in you go away very, very quickly. They go in, and the lipid part of this mRNA vaccine goes away within hours, basically, and the mRNA goes away within days to a week or so. So, and then that's completely gone. So there's nothing in your system left that can be altering your system other than your immune response to the virus. And so it's certainly possible that the immune response to the virus has some effect, but that's the same effect as your immune response to every virus you've ever been exposed to. It could be involved in something else, but the risks are very, very low. And boy, you put it up against the risk of infection and it's easy, an easy call.
Okay. Let's see. I think I've got a few more that have come in. Is there somebody, and you touched on this, but it's come up again. Is there somebody who should not take the Moderna or the Pfizer and wait because we don't have the J&J right now?
Yeah.
And I think you touched on it, but just if you can just.
Yeah, I want to be careful. I think again, so reminding everybody that I'm not an MD and that there's so many individual differences and that MDs are very important for, analyzing your specific case. But the people who should do a better, be a little bit more certain consulting their MDs are somebody who might be prone to anaphylaxis, because it looks like the anaphylactic response is unique to the mRNA vaccines. And then that would be the main thing for the vaccines that will be available to you, including the Novavax vaccine. And then the only other question mark I threw out there, and it was only a question mark, was children who are so healthy right now that their risks are very, very low, and that's a question.
What do you think we've heard different numbers, this notion of herd immunity.
Yes.
And you have thoughts on that, on how?
Well, I absolutely feel that the more people vaccinated, the better in this country and in this planet. So there's a lot of theoretical discussion about whether it's 70% or 90% or 85% or whatever. I don't think that's so important. It matters. It's a little bit dependent on some variables that we don't have enough resolution on to make a determination. But from where we are now to 95% vaccination is all good. Let's say it that way. And again, it's because there is still this looming later years or at the end of this year threat of new variants emerging, and the fewer of us that are percolating those variants, the lower the chance those variants will come back, and the virus will have figured out something that it takes it a long time to figure out, rather than something that takes it a short time to figure out.
To people that might be reluctant to want to take the vaccine right now, maybe they're waiting and they're concerned that maybe we don't really understand these vaccines, that this is all sort of mad scientist stuff. And what would you tell them in trying to help them make an informed decision on what they should be doing?
So I'll confess something that I'm hesitant to confess, and that I am 60 years old. And so as a 60-year-old, I became entitled to get my first vaccine, Palm Beach County, thank you. And it was a Moderna vaccine, and I lined up and I got it. And I was so happy when I did. So I still have to wait for my second dose. I'm not protected yet, but I am. It made me happy to have done so. And I think that for everybody I know, my elderly stepmother, my family friends who are the same age, many, as soon as available, many of the young people that I work with, I want them to get vaccinated as soon as possible. I know they'll be happy. I can't wait when they're all fully vaccinated to have that big party that we've been waiting for a year and a half. And that's how I feel about that. So we're making new vaccines. We believe in them, but I also strongly believe in the currently available vaccines, and that they will do everybody listening a lot more good than they could possibly do harm. I don't want to say the chance of harm is zero, but the chance of harm with that virus is very high. And these are very good vaccines. These are better than we could have imagined.
Well, I have to admit something to you as well. I got my vaccine. I also I'm under 65, over 60.
That's the word.
And so I was, I signed up, went online and signed up and I was able to get my vaccine. I did get a little bit of a soreness in my arm later, a few hours later. I felt that night, I felt a little, it didn't, I know I could tell something had happened, but I didn't, it wasn't enough to cause me to do anything differently other than to want to drink something and have something to eat. But yeah,
and as you know, that's a good thing, because the reason you feel very bad with the flu is not because the flu is making you bad. It's because your own immune response is making you feel bad. And we know it in science as the interferon response. And in any case, it's the kind of thing that makes you feel drowsy, makes your muscles ache, it sometimes even gives you a temperature. I'm not aware of many people getting temperatures from this thing. But all of those symptoms are kind of meaning that it's working. I almost regret that I didn't have much of, I had a sore arm, but I didn't have much else so far. And so that's not, my understanding of the word is that's nothing to be afraid of. That's something to be kind of happy about.
Okay. And then, with the second dose, would it have the same kind of reaction? Or I've heard potentially people get a little harder reaction or stronger.
Yeah, my understanding is, and I'm not experienced in this, that the second dose will be more serious. And that is also part of the joy of the immune system. The joy of an immune system is a boost is much more vigorous than the initial, what we would call prime. And that's what's, absolutely lovely about vaccination. The second vaccine, even with something a little bit different, maybe a new variant or something like that, will be much stronger. And so that's just absolutely great news. But corresponding to that, you're also going to have some, I've just talked to somebody recently who felt like they had to stay in bed much of the day. So that can happen.
Is this something we're going to be getting? So will we be getting, and you said you thought it potentially might last for 2 or 2.5 years, but do you think we'll be getting boosters every year?
I think we'll be getting boosters on a fairly regular basis. I think it'll correspond to a test. So you'll walk in as part of your blood work. They'll do your COVID levels against the currently circulating variants. They'll say, Mr. Farzan, we think your COVID levels are a little low given the prevalence of the New Guinea variant, and so we think we should boost you with that, and that will boost your response to not only the New Guinea variant but also your response to the previous variant as well. So it's just a great thing about immunity in that case. And so, yeah, that's what I expect. And I think from the longevity data so far, it will mostly be the variants, which are unfortunately a near inevitability, driving the need for boosters.
So we're sort of closing in on our hour, and but I wanted to offer you the opportunity to, if there's something you think I should have asked and I didn't, or if there's just a message you want to share with the folks that are watching you this evening, or will be watching because we're recording this later. Is there a message you would like to leave people with?
Well, okay, yeah, 2 messages, I guess. One is Scripps is doing great work on COVID and everything else. You guys should be proud of this institution. And number 2, there is no reason not to get vaccinated, every reason to get vaccinated with the currently available vaccines. I think that would be the take home, I hope, from this.
Okay, and I just, a message just popped in, and we've got a couple of minutes left. So let me ask you this. Do you have any thoughts about when it would be safe for people to travel, or large gatherings of more than 10 or 50 or 100 people? When would those kind of things?
There's a couple of metrics in that. First of all, for an individual who is fully vaccinated, so you've waited, after your second dose, you waited, I don't know, whatever the recommended, I think it's 10 days, you can consider yourself largely safe from getting a serious infection as a consequence of an exposure. So that's, for you as an individual, or for me as an individual, I will comfortably get on a plane with a mask after that point. So that's one thing. And I will comfortably enjoy a social occasion with other people who are vaccinated as well, of groups, say up to 10 or something like this, if they're presuming they're all vaccinated. And then the other thing I would be watching would be the number of infections in Florida and in Palm Beach County. And I would want them to, well, so the national numbers are still very high at 50,000 cases per day. So the national numbers really should be down to something like, way below 1,000 cases per day before, we're happily, going to I don't know, big events or something like this. But I think it's all coming, and I certainly am planning to have a big party with my lab on June 21st and enjoy 4th of July with my brother on July 4th.
Okay. Well, this has been really exciting and just a real, not only a pleasure, but an honor to have an opportunity to speak with you and know that not only are you working here in Palm Beach County, but you were educated here initially as a child here in Palm Beach County, and you've gone on to do this tremendous, work, and this research that you all are doing at Scripps is absolutely phenomenal. And as you said, it's not just on, the things you're doing with COVID, but so many other things that are so debilitating to our people and and to the world for that matter. Just amazing, amazing work happening right here in our backyard, and having all of you experts walking among us. It's very, cool is not the right word to use, but that's what comes to my mind. Because
yeah, I look forward to the day when we can make everybody excited about all the other work we're doing across the campus.
Well, I'd be happy to at some point we can have a discussion about that. One last thing before you go, somebody just dropped a note. If you don't get a reaction from the vaccine, should you be concerned?
No, no. You will get, I'd be kind of surprised if you don't get some soreness, which is all I got. But absolutely not. No, you will have a very robust immune response.
Well, Professor Dr. Michael Farzan, I can't thank you enough for giving of your time to us tonight, for sharing your knowledge, and I think helping to educate our population on the safety, the efficacy, and the wonderful work that you're doing and the new technologies that you're developing, and helping us all to understand what's going on and to be safer and healthier as we all move through something we, I think, never had envisioned. You all may have, but I think the rest of us had never imagined going through a pandemic like we've been through. And just thank you so much.
Well, thank you. Thank you for having me.
All right. Well, to everybody, I wish you all a very safe and happy evening. And, as we've been told, if you have an opportunity to get the vaccine, that's what's being recommended, to do that. And my office stands by to assist the rest of the government of Palm Beach County, your local municipalities. We're all in this together, and we're all going to get through this together. So have a wonderful evening, and it's been a pleasure.